Welcome back to the program. Good Morning Kenya continues. Now, GMOs were banned by the late former third president of the Republic of Kenya, Mwai Kibaki's administration. And 10 years later, the ban was lifted by the current regime. This has brought about so many questions, others being for it, while some people are against it, saying that it is not safe. Now, joining me in studio is Professor Richard Oduor, who is a professor of the biotechnology at the Kenyatta University, as well as Dr. Joel Ochieng, the Secretary General for Kenya University Biotechnology Consortium. Now, they are here to just unpack mystery. I'll call it a mystery because I feel like most people do not understand GMOs. So they are here to unpack the mystery that is GMOs. Welcome to the show.
Thank you, Vivian.
How are you doing this morning?
Very well, very well. How are you?
I'm very well, thank you.
Okay.
If you can just go directly in and define what genetically modified crops are.
Well, ordinarily, when you have, for instance, maize, if you want to improve it against, say, insects, then under normal circumstances, you can use pesticides to spray and you kill the insects. Unfortunately, when you do that, you're killing other insects that are not even interested in your maize, but you have killed them anyway. Or another way is to make them, tolerant to the insects by way of finding out what is this that naturally kills the insect, and you are able to transfer it to maize. So how does it start? You first of all look at, do we have maize out there that is tolerant to insect? So if that maize is there, then you take that maize with yours that you like, because the other maize could be there, tolerant to insect, but does not yield. It gives you smaller yields. So yes, it is tolerant to insect, but it's not giving you the right yield. So it is not good. Then the one that gives you the best yield is susceptible to the insect. So it's equally not good when there are insects. Under that circumstance, the natural thing to do is to take the other maize that is insect tolerant, and the one that gives you best yield, you cross them so that the offspring, which in this case we call hybrid, gives you a bit of the small yield that you can get from the one that you preferred, and the other one gives you tolerance to the insects and it's not the one that you preferred, but the only thing you are looking from that is just the insect tolerance. And the only thing you want from this other one is the bigger yield. Now, when you mix them conventionally, then you'll get 50% of that one that gives you very small yields and 50% of this one so it comes together with all the bad things. Probably it was very short, it was not tasty, but you have taken all that. Now, genetic engineering is whereby you go in and say, I don't want this particular maize. The only thing I want here is the insect tolerance. Because that thing that makes it become insect tolerant is a gene in the genome. That is why it's not normal that the entire maize is just the leaves. There are sections that are stems, there are sections that are roots, others are just the leaves. And why is it that way? It's because the genome, which is the DNA in there, is also cascaded or also separated or compartmentalized in different sections. So there is a section that is responsible for the leaves, there is a section responsible for the stem, and another one for even the insect tolerance. So genetic engineering means that I can go into the genome, because naturally they are mixing anyway. I get into the genome and only identify the section that is responsible for the insect tolerance. That is what I cut and bring it into the genome of this other maize, so that this maize continues to have all the traits of the bigger yield and everything else, but now I've moved the gene naturally, from that source to this. At that particular point, it's called transgenic. It's a GMO now, because you have genetically engineered, you have moved a gene, a DNA, from a source which is not natural, because naturally you cannot only pick that section of the DNA alone. But you see, naturally you're still eating this. But that is one. Under that circumstance, because it is maize for maize, we call it cisgenic. From the same source. But assuming you now, for instance, if we realize that In the world now, we are suffering from the nutritional problem. When you eat githeri, you find there is maize and there is also beans. Okay? You take maize in there because maize gives you carbohydrate, right? And then the beans in there is giving you proteins. Very basic. Naturally, when they're in your mouth, you are mixing the DNA. You never go in to remove the DNA from the beans. It's in there. It's in the cells, really. Now, assuming now we have a problem with insects that are attacking beans. At that particular point, we are losing beans naturally. And those are things because climate change is here with us. So ordinarily, do you know what we needed to have done previously? We just needed to we don't eat beans because we like beans. We are only actually looking for proteins, nothing else. For maize, all this eating, chewing is just because we are looking for carbohydrates, nothing else. So ideally, if we can't get our beans because of a disease and climate change is here, you cannot also, there's a more advanced example, you cannot cross beans and maize so that you get something called binomaize something. You know, you can't do that naturally. So that is when again we come in and we say, okay, you know, maize and beans are both plants. How come that maize is producing only carbohydrates and beans are only producing proteins? You know, and we need both. That is when now we come in and say, all right, let's get into the genome of beans and identify the gene that is responsible for only proteins. We don't want the leaves of the beans to cross into maize. We don't need those genes. And naturally, we eat the DNA anyway. So we take that section through a process that we are calling genetic engineering and move it into the genome of maize, only that section that is responsible for the proteins. So at that particular point, Vivian, that maize is called GMO. And all of a sudden, it has become so bad because it's now killing. And we should really refuse. When did we become this ignorant as a country? Thank you.
Very well explained over there. We'll get back to that. But we know that maize is a staple for
ration and shriveling. So we are improving food safety, we're improving market access, and we're improving food production using biotechnology.
Okay.
Yes.
Right. We've talked science. And I feel like we should just get into maybe what the person who's watching would really, really want to know. You know, we've been having demonstrations, and the main reason why the demonstrations are there is because the high cost of living, especially unga, people are fighting for the prices of unga to go down. Will GMOs help in lowering the price of unga?
Of course, yes. Excuse me, Vivian. You know, it's unfortunate that we are going through the mandamanos now. And it's also justified that people are missing what to eat, and the cost of living is way high. But we also must accept that this has been caused by natural calamities. One of them is that we have gone through several seasons of drought episode. And this is when we come in. It's also important for people to probably understand that this country has the capacity to feed itself through science, through just adopting better agronomic practices that will enhance food production. For instance, look at drought. Drought is as a result of a climate is shifting, or what we commonly call climate change. Fine. But do you know Israel is desert, is a desert?
Yes.
Egypt is a desert. Morocco, and before we came in here, we were catching up with one of our friends, Giorgio Rido, and he was saying Morocco is holistically desert. But they are doing something about it. Now, when there is drought, you choose either to go through irrigation, it's one way, and if you are privileged with a lot of water bodies and therefore you can do irrigation, that is fine. You might find yourself that you don't even have water bodies that you can use for irrigation. If you are surrounded by salty waters, then you go through very crazy processes of reverse osmosis to remove the salts and then get your clean water, use it for irrigation. That also has another problem later on, because where are you depositing the salt? Again, later on, they also have their pros and cons. But now genetic engineers like ourselves, we ask just one single question. When there is drought, is there any plant that is growing in a drought environment? That's the only simple question we ask. Then you'll realize you go to Northeastern, you'll find cactus, sisal. You'll find them growing. But human beings, we don't eat them as Kenyans. By the way, If we would move from eating maize to eating sisal when maize is not available, we won't be here. But human beings are also very funny people. Their eating patterns are so consistent and they don't want to change, and particularly Africans. If we eat our githeri, you give us actually, rats to eat. We start jumping left, right, and center saying, oh, rats, how? You don't like us. This is so bad. Yet proteins in rats and protein in beans is the same. The amino acids are only 20, and it's documented. It's not different. This is what the Chinese have already known. That's why when they find a frog, they eat, because carbohydrate is carbohydrates. They find, anything else, they eat. And it is the basic way. So we need, first of all, to even start thinking about liberalizing our eating profile. But that's a bigger process, because eating is a function of culture, is a function of preference. I eat omena, for instance. Some people in this country cannot even look at it. True. And it is not banned, it's not GMO. Why? It is because there are other ramifications that go with food and eating. The only problem that we have with GMO is that every other person thinks that every problem that they have in this world is GMO. Now, this is how we sort your drought tolerance so that your prices go down. What question do I ask? What plant is there that is drought tolerant? If I find that it is sisal, then I ask myself, what exactly is making it tolerant? Drought tolerant. You might realize that if you look at the leaves of this sisal, it's succulent. The leaves are succulent, and it's shiny on the top. So a bit of basic physics will tell you that if something is reflecting, when the heat hits it, it's reflected back. Very little is absorbed. So that trait is important. Maize doesn't have it. Probably you might realize that the roots are longer. So you see, if we have 1 kilometer length of a root of a maize, we'll never have a problem with the drought, because at least a kilometer down there is some water. You see, so we will not deal with that. So probably the roots are longer. Now, as a genetic engineering, I ask myself, my people are still stuck with their maize. Sisal is here surviving on the drought environment. Take your maize and sisal cross it, it will never happen. How do I help? Then genetic engineering comes in. What do we do in genetic engineering? Because my role today is just to unpack this GMO so that you refuse it knowing what it is. Just like some people have refused omena, not because it is toxic, it's because it's a choice. That is the level of the discussion we want to have in this country. So a genetic engineer like myself, what I do, I go into the genome of the sisal. You sequence it. There's something called sequencing, because everything that is alive, and this is important for our viewers to know, insect, plant, cassava, anything that you see has life, has a cell. In the DNA, in that organelle called the nucleus, there is DNA. DNA is nothing really complex like people want it to sound. DNA is just made of 4 letters that are joining themselves in several sequences to form a string. Just like alphabets, there are 26, right? But all the words, English words, are coming from alphabets. You are Vivian. If I tell you to write your name, will you go for P? No. You will pick V, you go for I, you look for another V, and you go for I and A. Now in the same alphabet, Joel comes and writes his name from there. He won't pick the V. He goes for J, O, E, and L. Myself, Richard, I'll go for my R, and we are still playing around within the same alphabet. Now, that is how the genome is. The genome has 4 letters, A, T, G, and C. There are only 4. Even in rats, there are 4. In mangoes, there are 4. So, what's the difference? These 4 letters, A, T, G, C, are the ones that are repeating themselves in a particular sequence. So in human beings, for instance, these letters have repeated themselves 3.2 billion times. It is sequenced. Way 20 years ago, that has been done. Sequencing is the most basic, we have next generation sequencing, because you cannot start doing genetic engineering before you know what are you pulling from where. So back to my sisal, what do? Sequence the genome of the cassava. Then I only need 2 genes. Remember, right now I only need 2 genes. I don't want the sap, because it is, sisal is a bit bitter. That's not what I want. I just want the cuticle. And that cuticle, I'll take it to the maize leaves. Then the root, if it is longer, the root elongation, I pick only 2 genes from sisal. One responsible for the shiny cuticle and one responsible for the root elongation. That is what I move to maize. So that maize has longer roots and shiny cuticle. We don't eat the leaves. We don't eat the roots. We are not tampering with the kernels. At that particular point, that maize is GMO. But the kernel is the same. The color is the same. But it is so bad. people don't get GMO. People don't get what genetic engineering, and I want to really say this now, because in this country we have laboratories at Kenyatta University. They're coming from. Who do we even know how it's done? Kenyatta University are from the late education that time. 05 to now, we're talking about 18 years. I did my master's in that very, very lab before leaving this country for a PhD and postdoc. All right? So it's done. In this country, we have one lab in Kenyatta University, another one in Il Rebecca, another one in Calro, another one in Isipe, and all other scientists and the universities that are here are actually doing this genetic engineering. Joel, when he wants to do genetic engineering, which he does, he goes to Calro, goes to Kenyatta University, goes to Isipe, so it's available here. So it is not new. And therefore, when people jump around left, right, and center, I tell them, we have drought-tolerant maize here at Kenyatta University. I want them to come and see and check what's happening. We have cassava here that is cyanogenic. We have maize here and sorghum that is tolerant to striga here at Kenyatta University. People need to understand that any person who talks about GMO without understanding actually is messing about with the future of this country. Because let me tell you what this ban has done. For the last 10 years, imagine you have slowed down a country that many others, and we can no longer now benefit from the technology. Do you know what that has done? And sometimes I feel that this is a very well-organized way of ensuring that African countries, and Kenya in particular, how does it become GMO product was sold in 1996 in the US? And in Africa, we have 8 countries that are enjoying GMO. China is eating GMO, Australia eating GMO, Canada is eating GMO, US is eating GMO. And you still think that those countries would want to kill their populace? Really, as a country.
On that thought, Professor, we will take a short break, but when we come back, we will continue with this discussion. And there's the question, there are fears that Kenyans have that GMOs are linked to cancer. Is it true, or is that a misconception? We'll find out after the break. Back to the question on cancer. Are GMOs linked to cancer?
Yeah, thanks, Vivian. I will answer that, and just briefly, to add on to what you said about, you had asked the question as to whether GMO can reduce the cost of hunger. The answer is yes, it will. Is that data from countries that have grown predominantly GM maize, for example, let's talk about one product. Predominantly GM maize, internationally, we have compared prices through research, and their prices are far lower than the rest that grow conventional maize. 2 is that the process eliminates several things that cost the farmer. It eliminates spraying. For example, BT maize eliminates spraying, and that lowering of the farm processes, the inputs, which is sprays, and second to that is that there's less pest damage, so you harvest more. And based on those kind of outcomes, it means that now you can be able to sell the retail price lower. Even when we imported GM maize, when that was authorized by 2011, it was much, much cheaper than normal maize. So there's enough evidence on the three fronts that it will lower the cost of hunger. So we're talking about something that we have evidence we lower the cost. Were lower, the retail price was lower. The countries are selling them at lower prices compared to the conventional maize, and the inputs, the farm inputs, are eliminated.
Okay.
Yes. Now I go straight to the question of cancer.
Linked to cancer, yeah.
Now the first thing is that I will now segment this thing we are calling GM into different varieties, because we cannot balkanize and call GMO. Then I will now address the umbrella word GMO. Now let's talk about the one that was to be deployed on the farms in Kenya, which is BT maize. I can tell you, and I live here, where will I go for my food? BT maize has no health concern at all. And not just me, nobody anywhere in the world, not even in Kenya, has ever raised any health concern about BT maize. The ones we have been hearing concern the one that we use, Roundup, glyphosate, and that is not to be deployed in Kenyan farms. And even then, that Roundup is available in the agrovet, even today. I was born when it was here. the one that people claim that may cause cancer. Of course, that kind of research that was published has been disputed and withdrawn. But the one we are deploying on Kenyan farms is made from BT, the Bacillus thuringiensis, that you naturally eat. And that, now the process of GM development, let me put it clear, begins in the lab. And that process is controlled and tested. We test it at the cell level. And it's not just the developer who does the testing, it is the regulator as well. We have an institution in Kenya called National Biosafety Authority that is involved in the research of GM development from beginning to the end and beyond the end. By beyond the end, what I mean is that they check everything we do from the lab to field trials, to test on model organisms, to test on humans, to test in all manner of ways, including environmental tests. And they go beyond that, because for them, they go into market surveillance as well. And this is one of the most regulated products on earth, even beyond drugs. And when you hear a product has been approved, you should know that all those tests have been proven to be safe. Yeah. So I can tell you there's no problem.
Yes,
and
I also read that there's a research that says that it has no link whatsoever to cancer. If Prof, you may just take us through some of the myths and misconceptions that we need to demystify very fast, as I can see time is not really on our side.
Thank you so much, Vivian. When you talk about GMO, these are the following things that pop up. There is, people say that it causes cancer. Joel has told you it doesn't, and Joel has done a lot of publications on cancer. The next thing they'll tell you is that it causes infertility for the women, and for males, impotence and all that. And let me just say here, because I make GMO at Kenyatta University, it's normal. If it is true that the GMOs indeed truly cause impotence or cause infertility, I can tell you we cannot afford it. Because at that particular, my postdoc was in Pfizer. I did drug discovery. So I can tell you the cost that pharma industries go through to develop contraceptives for women and to vasectomy for men. We cannot sell to you GMO in your table if it is a drug that causes impotence. We will package it, it will be rebranded, and it will be sold as a drug. You will never get, you can't afford it. It is wrong, it's not true. Then they'll tell you, you see, GMO seeds don't germinate, and therefore these guys want to control the seeds. And I look at them and tell them, look, the idea of buying seeds every season is not a preserve for GMOs alone. Even the hybrids that we have, natural ones, you are advised that every season, you must buy seeds. And do you know why we buy seeds? It's because they're hybrids. They lose their vigor. There's something we call hybrid vigor. So you need to buy them every season. But of course, they'll tell you there's a terminator gene. They have put terminator gene. There is a UN moratorium that terminator gene cannot be used in development of GMO. Plant your GMO seeds, you will still get them, they will germinate, only that because of the loss of hybrid vigor, or just the vigor, not hybrid in this case, but the vigor as such. But because when you're making the seeds anyway, you've also bulk them. Even if they're GMO, you still do the hybrid in terms of getting, pyramiding and, consolidating some of the traits that you want. And Joel can take you through that very easily. That will also be critical. The other thing they'll tell you, it's actually killing biodiversity. And I ask a question, what do you mean it's biodiversity? When the BT maize we are talking about here, you have put the gene that is responsible, that kills the insects in maize. That means that only the insects that will eat the maize will be the ones dying. And under natural circumstance, we spray. And when you are spraying, you spray more than even 4 or 5 times for some of these things. And in those 5 times, one thing that is happening, the pesticide is actually getting to the soil, killing all other things that are not even interested in your maize, and when it rains, it gets to our water bodies, and we go get that, and we swallow that, you know, the chemicals. That's the disadvantage of this. So genetic engineering, what it has done, we are putting it into the genome. And let me give you an example. When you're privileged to have a baby, you take them for vaccination. Is it usually because you think that God did not complete the work? You know, and that you are now very innovative, and I hear people say that we are competing God. Which God? How can you compete God when you're using the DNA that he's the one who created? We probably don't understand really the strength of God when somebody says so. But now, why do we vaccinate the kids? We do that because we want them to have the antibodies that will protect them. Now, if we are doing that for human beings, our own babies, you think we can't do that for maize? Why can't we vaccinate the maize? The only reason we are not vaccinating maize is because they are in thousands in the farm. So injecting each and every one of them is almost ridiculous. And that is why we've come up with a method where we are saying, put them in the genome, so that we don't need to keep vaccinating. In the genome means, by the way, if it becomes very useful that we need to put these vaccines into the genome of human beings at the sperm level, so that the kids come already born with vaccines already in their system, it will be done. Only that right now the vaccines are working. When the vaccines will in the future fail to work, and therefore we still need to vaccinate, we will think about other, these things that we put out, we will put them in the genome at the sperm level and the ovum level, so that the child comes out already vaccinated. It is possible in the genome. Then the other thing they will tell you, you see GMO, who owns the technology? Whoever controls food controls, you know, the people. And I'm like, come on. There is no country world over that has the monopoly of technologies and of IP. If it is true, look at the vehicles that we are driving in this country. We import them 80 years from the other part. Actually, they are old. But they come here, we brand them with the new number plates, and we have the newest number plate, and they cause accident, but we still have them. How did we get ourselves to importing vehicles that we don't even have the IP about? What I mean is, if there is technology out there that will serve this country, good governance, governance, what, you know, the governments, what they do, you go and tell these owners of this technology, this we have realized you have an IP on a drought-tolerant maize. Kenya, we have drought. We want it under the following terms, so that you negotiate the very way we negotiate. We don't make drugs in this country. We get them from Pfizer and Novartis. Well, how do we get here? Who controls that technology? So how does it become special when it comes to food that we eat, which is more paramount? All these things are just, you know, academic talks. They are just, you know, talks that for people who don't really understand what genetic engineering really means. And now we are in the latest, which we are calling genome editing, probably for our next sitting. Okay, I feel like this conversation, we might need more time for it, because my producer is already telling me that we are out of time. We need to have you guys back probably soon, so that we can unpack more of this. But just as we finish, you mentioned that we are already taking GMOs unknowingly, right? We are already taking it. So that is something I feel people should know, that we've already been taking it for years. Maybe there are some that we've been taking unknowingly. My last question to you, gentlemen, will it be easily available? And who is controlling? Who will be controlling it? And will it be easily available for the farmers? Matters cost.
Yes, now that's the question I really wanted to tell Kenyans about as we exit. The first thing is that the GMO that is available for farms to be planted in Kenya, the BT maize, is not a foreign product that is going to come from some Mzungu country, as many people have been alleging. It has been developed here locally through what we call public-private partnership. That's government plus private sector, researchers in the universities, CalRO, and other private sector players. So it is not subject to any intellectual property issue. It is not subject to any royalty. It will be available here, and it is already available here, but as you know, there's a court order. So that's what we are waiting for. Once the court issue is done, and hopefully it will go well, as these are Kenyans and they believe in our food security, then it will be deployed in Kenyan farms. So it's a local product. It's not brought from somewhere else, that somebody can come and say, now we are refusing to give you seeds. Next season we are not bringing seeds. It's not to be brought. It is here, developed here. Okay. That's what I wanted people to know. Okay. Okay, my time is up. I really hope that you guys will make time for us. Sure.
soon enough so that we can finish, because I have so many questions that are left unanswered, but due to time we have to go on. Now my colleague Ram Aguko will be coming in next with, and they will be tackling a discussion on low self-esteem. Where we are as a country right now, I feel like that is something that we need to talk about. Thank you so much, gentlemen, for coming to the show.
Thank you.
Thank you.
Right.
Good morning.